Remember a little bit what we did on Friday? We were looking at, well, example 1. I'll just go back to it. That's not example 1. Here's example 1. Example 1, we looked at this in front, that -1/4, and found out that we had a vertical reflection and then, in this case, a vertical compression. And everything in front of the function, outside of the function, that affected things vertically. Now in example 2, we're looking at a value that's inside the function. So everything inside the function, that's going to affect things horizontally. And in this case, even though there's a 0.5 there, it's going to be a horizontal stretch. So we can think of this 0.5, another way of thinking about 0.5 is like, oops, a half, I forgot the g of a half of x. And everything inside the function for stretches and compressions, you're going to multiply by the reciprocal. So the fact that there's a half inside says you're going to take your x values and multiply by 2/1, or just 2. So we're going to take our key points from our original graph. So we have the point -3, 2. That's this one right here. We've got -1, 5, 3, 3, and 4, -2. Those are the 4 points on our original graph. And as a transformation, what we're going to do to each of them is do that horizontal stretch by multiplying our x values by 2. Our y values don't change, only our x values get multiplied by -2. And once we've done that, we can now label those points. Oops, that one's too far. And connect the dots. Now visually, what we imagine with a horizontal stretch is you're grabbing hold of your graph on both sides and pulling it away from the y-axis. The only point that doesn't change is your y-intercept. Your y-intercept will stay the same because on your y-intercept, your x-coordinate is 0. I believe this one's at 0, 5. No, 4.5. And if you multiplied that x-coordinate, which was 0, by 2, it's going to stay 0. So it should make sense that my y-intercept is the value that's not going to change. Everything else gets changed and it's stretched horizontally by a factor of 2. So now if we state the domain and range of each function, well, our original function, looking at our graph, the smallest value for our x values is -3. -3 less than or equal to x, and our largest value was 4, less than or equal to 4. Our range, our smallest y value on our red graph was -2, less than or equal to y, and our largest y value was 5. Going to our new graph, our image graph, our domain now goes from -6 to 8, and our range stays the same. So again, we see the horizontal stretch when we look at our domain and range as well. Notice our range didn't change. That's because we were doing something horizontally, only affecting the x values. But our domain, it did change. And it changed. Look at the extreme values of -3 and 4. They've been doubled because that's what we did. We've multiplied our x values by 2. Okay, try 4 and 8.